All right, so we are doing 6-3, and 6-3 is analyzing rotation. So just as a very quick recap, ladies, as a very quick recap, we have done translations, which it's slides. When I was in college, I took a class and it was called analytic geometry or taxi cab geometry. And the reason is because if you think if a cab picks you up and they're taking you to the theater and it's 3 blocks up, 5 blocks up, that's just it. It's just 3 blocks up, 5 blocks over. Like that's translations. You just like you're driving a cab through the city and you go up 2 blocks or 3 blocks and you turn the corner and you go over 5 blocks. Okay, that's translations. If we're talking about reflections, the big thing there is the line of reflection and the image, same shape, same size, but the orientation changes, meaning it flips over. Think of a turtle getting disoriented, right? It flips on its back. And so that's what a reflection is. And it always reflects across that line of reflection. And so the most important thing about translations is knowing how much does it slide up, down, left, right. The most important thing about reflections is where's the line of reflection, because that will determine where you put your prime image or your image that you get after you rotate or after you reflect the pre-image. Okay, so now we're going into rotations. For me personally, I think rotations is the hardest of the 3. It's not that it's harder. It's just if you are not a mentally visual person, I think rotations can be a little challenging, and that's where I'm at. I'm not a mentally visual person. I have to see it, feel it, do it, black and white. Like I need to be able, and a lot of the rotations work, it's a lot of mental thinking. And that's why for me, it's harder. If you are really good at that, then this will probably seem easier to you than maybe translations or reflections. And it's just because everybody is kind of a different thinker, a different kind of learner. And so some things are easier or harder depending on your learning style. Okay. If you're really good at that, then you'll probably be a great interior designer or something like that, right? Or an architect or somebody that can see something and like visualize it and then make it happen. Yeah, that is not me. So, all right. So the first thing we're going to talk about is this Ferris wheel. And it says Maria boards a car at the bottom of the Ferris wheel. She rides to the top where the car stops. Maria tells her friend that she completed 1/4 of a turn. Is she correct? What do you guys think? If she's at the bottom where she loaded, and this isn't what I want you to highlight. This isn't why I want you to have your highlighters. You guys are like the one class that it loves to do that, and I don't know why. Hopefully it doesn't mess up the recording. Okay. This isn't part of what you need to highlight. I'll let you know when I actually want you to highlight something. So she's down here. She loads the Ferris wheel at the bottom. She ends up at the top. Did she go 1/4 of a turn? What do you guys think? Corbin, what'd she do? Yeah, she went 1/2 a turn. Okay. So it's just recognizing that 1/4 of the way is 1/4 of the way. 1/2 of the way is the opposite side of the Ferris wheel. And then 270 would be another 1/4 turn. And then a 360, if you've ever heard kind of the slang, she did a full 360, means she did a complete turnaround. Okay. And so that means going from starting point all the way around back to starting point. Okay. So I want you to go ahead and just jot this down just to make sure, because you are going to have to state angles a lot in this unit. I want you to get familiar with the 4 most popular. Now there's other angles, of course, but these are the 4 kind of main ones. So I'll give you a minute. If you're at home, pause the video, make sure you get this written down. All right, so 1/4 of a turn is considered a 90-degree rotation. A 1/2 a turn, which is what she did on the Ferris wheel, is considered a 180 degree, and it creates a straight angle. And here's why. Notice it goes through the center or the rotating point of a Ferris wheel. Think of the pin that they have to put in place right in the center of that Ferris wheel to make that Ferris wheel spin the way it does. So the rotation point for a Ferris wheel is the center of the Ferris wheel. And if you're talking about 180-degree rotation, it means that she goes from the bottom straight through the rotation point up to her ending point, okay? And that creates a straight line or a straight angle, okay? And if you were to measure from here to here, that's where you get the 180 degrees, okay? A straight angle is always 180 degrees. Now, if Maria, if she stopped at a fourth of a turn, right, like she thought, she would be right here. And if you go from the center and draw a ray out to that spot and draw a ray down to the beginning spot, you can see that that creates this 90-degree angle. So a quarter turn or a 90-degree rotation, okay, if you put a point at the center and then radiate out to starting and ending points, it will create a right angle. So if you're shown a rotation and it puts the little right angle box in the angle, you know it's a what? What degree? It's a 90-degree rotation. If they put the little box in the corner, that's your indication that it is a 90-degree rotation, okay? All right. Now, I know a lot of times you guys probably don't love that I have you write stuff out, but especially for this section, this is going to be vital. And every time you say, I don't know what they mean by describe it, I'm going to say, go to page 321. So the first thing on the underneath that part A, and this isn't answering part A, this is just using the space. I want you to write how to describe, and this is where your highlighter comes in. Please highlight the words, how to describe. Okay. And then go ahead and list those 3 things that you are going to use every time you describe a rotation. So I'll walk around, make sure everybody gets this. Please highlight the how to describe. This is all under that hat, the left-hand side of the page. We'll put something on the right-hand side of the page here in a minute. Did write what I told you to write and then highlight. What's the heading say? Please write and highlight that. There's a reason why I need to be here. Beautiful one that I'll let you borrow. Just make sure I get it back.
Alyssa Hamilton is the offense. Alyssa Hamilton is the offense.
All right, so when you are asked to describe a translation, you use words like up, down, left, right. When you're asked to describe a reflection, like our jump start, you say it reflects across the, and then you state what the line of reflection is. When you're asked to describe a rotation, a lot more goes into it, okay? You have to say if it's rotating, how many degrees, okay? 90 degrees, 180 degrees. You have to say whether or not it's going clockwise or counterclockwise. And then you have to say, and notice about the, notice that the words about the are in quotations. That means you're going to write it exactly like that. So as an example, we could say that the image rotates 90 degrees counterclockwise about the, that has to be in there. And then you're going to say, what does it rotate about? If you have an umbrella and I open my umbrella and I point it toward you and I spin my handle, you're going to see on your side, you're going to see my umbrella spinning about the center. right? Because the center of the umbrella is the pin point or the rotation point. The other thing you're going to see, and I apologize to you at home because you can't see what I'm doing here, but there's also an option to rotate about the origin. So I've got this up here because I've been using it all day. So if something rotates about the origin, remember on a Ferris wheel, you put a pin in the center and that's where it spins. If this triangle rotates about the origin, you put a pin in the origin, right? And the triangle rotates about the origin, okay? And that would be a 90-degree rotation clockwise, because I went same direction the clock hand goes. So this would have been a 90-degree rotation clockwise about the origin, because I rotated about the origin. I'm not sure if you guys do that in this new curriculum. There's an overlap and there's some new things that we do and some old things that we don't do from the old curriculum. But there's also the option to rotate about the B. And what that means, or about the A or about the C or whatever, but I'm gonna use B as an example. If this triangle rotates 90 degrees about the point B, means the pin goes in point B, and you would rotate it 90 degrees from there, and B would never move because it's the point of rotation. Okay, so if you'll think about it like the pin idea, where whatever you're rotating about, that's where you stick the pin, and then your image rotates about that. If this triangle rotated about the center, okay, and this is, I'm just gonna say this is the center, this is what I got to hold on to, it would rotate like that. Okay, because it rotated the pinpoint, the part that didn't move was the center of the triangle. Okay, if it rotates about the origin, it changes complete, right? And if it rotates, usually round things tend to, not all round things, but like we're gonna do a square here in a minute, but triangles usually don't rotate about the center, but because it's kind of hard to get the center of a triangle exact. All right, the next thing I want you to write down is that, and this is important because you're not always going to actually have the words clockwise and counterclockwise specifically given to you. So you have to know that a positive degree, write this down and highlight it. Notice this is one of those big important things. Draw a box, highlight it. Eli, you got it? Positive degrees rotate counterclockwise. Negative degrees rotate clockwise. And this is extremely important. Okay, so with this knowledge, you don't have to write this part. I just want to ask you, with this knowledge, does negative 45 degrees and 45 degrees clockwise mean the same thing?
Yes.
Yes. Sometimes it's not going to actually explicitly say the words clockwise, counterclockwise. Sometimes you're just going to see it like this. It's going to say negative 45, and that's where you have to know that the negative means clockwise, which clockwise is going this direction. Think the way the hands of a clock move. Sometimes you will see 90-degree rotation, and it doesn't say clockwise or counterclockwise, because if it's not negative, we know it's positive. And if it's positive, we have to fill in the blanks that it's what? Positive would be what? Counterclockwise. So you've got to have that knowledge and be able to interchangeably mix the way it's written. Sometimes it'll be negative 45 degrees, and that's all you're given. And you got to know that that means a 45-degree rotation clockwise. Sometimes it'll be positive 90, and it won't say counterclockwise, but you have to know that because it's positive, it is counterclockwise. And counterclockwise goes the opposite way of clock hands. That's why it's called counterclockwise. Okay? All right. A lot of definitions kind of at the beginning of this, but taking the time to do this is helpful, because when you guys are doing your Savvas homework and the directions say describe the rotation, and you raise your hand and you say, how in the world do I describe a rotation? What am I going to tell you? Go to page 321. Yes, that's why I'm having you write this so explicitly. If you do not have this written down, where can you find it? Canvas video. Okay, I'm recording this right now. Scoot forward in the video, pause it, make sure that you have it written down where you can read it, because this is vital information. Okay, all right. So let's talk about a couple of examples of this. So we've got the good old architect. We've been dealing with this architectural patio picture now since 6-1, right? So it says one feature of the new patio plan is a rectangular umbrella that can easily rotate so the clients can enjoy either the sun or the shade. Where should the architect move the umbrella to highlight this feature for his clients? Now, they just tell you right here, and just highlight this, okay? They tell you this right here. Okay, this is what the architect should do. He's going to rotate the umbrella 90 degrees counterclockwise. And we knew it was counterclockwise because of the positive 90, right? Now, I'm not going to have you write it again, but you're going to verbally tell me. Where it says model with math, it says, how can you describe the rotation of an umbrella? Somebody tell me the first thing you use to describe the rotation process. First thing. Eli, what's step 1 of describing a rotation? What is the first thing you use to describe a rotation? Page 321, number 1, how to describe a rotation. What's number 1? The degree. What's number 2, Brady? Clockwise, counterclockwise. What's number 3? Casey. What? About the, and then fill in the blank. Good. So anytime you see the words describe the rotation, you got to go back to those 3 things that are required. Okay. Now, if you put negative 90 degrees, do you have to put the words clockwise? Okay. It means clockwise. And so if you are kind of thrifty enough with your terminology that you know that negative 90 degrees means 90 degrees clockwise, you're good. You can put 90 degrees and not actually write counterclockwise if you know that plus 90 degrees actually does mean counterclockwise. So hopefully that helps, might save you a little bit of writing to remember the signage. All right, so the architect is going to rotate the umbrella 90 degrees counterclockwise. So let's look at the original image here. And we know here's the center. Think about how you would spin an umbrella, right? It's going to spin around that center. The only way to really see this is to pay attention to the color scheme. The dark blue is up here. He's going to rotate counterclockwise, which means this direction, so that the dark blue should be there on the left, right? So you're going to have to kind of notice how the color pattern changes to see how this spins. The shapes or the stripes are on the bottom, and those are going to rotate 90 degrees. And so what ends up happening is you get this image. Notice now that solid blue now is over on the left. It rotated 1/4 of a turn. So now what was at the top is now over on the side. Okay. And that's just what this is showing. It's the final image. Okay. Now, I want you to highlight this again, just to make sure it's in your brains. Okay. A positive angle of rotation turns the figure counterclockwise. Okay. And we'll just keep driving that home because that's so important to have in your brain. So everybody highlight that. All right, the architect continues to rotate the umbrella in a counterclockwise direction until it is in its original position. What is the angle of that rotation? So let's think about what happened. He started out here. Everybody, I want you to do this. Okay, he started out here. He rotated counterclockwise, and we know that rotation was 90 degrees. Then it says he rotates it all the way back to its original position. and it wants to know what is the angle of that rotation. What's a full rotation? 360. What's 90 minus 360? Because 90 was the first turn. We just want the red part. Brady? 270. Now, do we need to put the words counterclockwise? No, because why? We used what? A positive 270. Good. Everybody good with that?
Yep.
If you can remember a full turn, a full rotation is 360, you'll be good to go on this part. And if you've ever heard like slang, like she did a full 360, I mean, she did a complete turnaround. It means going from start all the way back around to start, kind of like Ferris wheel. You get on at the bottom, you've done a complete 360 when you get back off at the bottom. Nobody wants to get off of a Ferris wheel unless you've done a 360. Bad things, right? That's a bad day. Oh, there you have it. Unless you have a wingsuit. All right. Are we good with that? Let's see. How does an image compare to its pre-image after a negative 45-degree rotation? What do you guys think? First of all, you got to pay attention. It's a negative 45 degrees. So that means it's turning which way? Clockwise. All right. So how does the image compare? It is rotated 45 degrees clockwise about the center. Did I properly describe a rotation? Did I mention the degrees? Check. Did I mention clockwise or counterclockwise? Check. Did I say what it rotates about? Check. Okay, so all three things are in my description. So that is a very good description or explanation of what happened with a negative 45-degree rotation. All right, very good. Let's see. All right, in example 2, this one is so incredibly helpful. Let me erase some things here just from when I did notes earlier in earlier periods. Okay, the first thing I want you to highlight here with your highlighter, underneath the words example 2, it says, what are the coordinates of the image trapezoid ABCD after, here's what I want you to highlight, a 90-degree rotation about the origin. Is this rotation going to be clockwise or counterclockwise? They don't tell you. They do, but they don't. Chase? Counterclockwise, because it is a positive 90 degrees. Okay, so we know it's going to be a counterclockwise rotation about the origin. Underline the word origin. That is vital to know because there's a shortcut when it's about the origin. We love shortcuts, right? Because without the shortcut, you would have to get graph paper. You would have to graph the original point. Then you would have to get a compass and you would have to figure out and go point for point and take every single point and rotate it 90 degrees counterclockwise, and then draw your new image based on all 4 of your points being rotated. It's a very difficult way to do it. It's doable, but it's difficult. But we have a shortcut, which is why you're going to highlight this. Underneath that generalized box, I want you to highlight that entire box. You are going to go to this a lot in this unit. Okay, everybody put a highlighted square. Dayton, you got the highlighter in your hand? Follow directions. Okay, I promise there's a method to my madness. And I want you to highlight and underline, star, whatever it takes to bring attention to about the origin. This shortcut only works if it's rotating about the origin. If it's rotating about the center, or if it's rotating about point A or something like that, this doesn't work, okay? All right, so here's how the shortcut works. If something is rotated 90 degrees, your original XY, okay, flips, the X goes in the Y spot, the Y goes in the X spot, and notice the Y turns negative. So if it was a positive 2, it becomes a negative 2. If it was a negative 3, it becomes a positive 3, okay? X sign stays the same, Y sign changes. If it rotates 180 degrees, the X and the Y stay in the same spot, but they both switch signs. If it rotates 270 degrees, notice the X and Y change places, and what was a positive X turns negative, or if it was a negative X, it turns positive. So this takes a minute, like it just takes a little bit of patience to do this, but this is so much easier than graphing the original and then taking your math tools and spinning everything 90 degrees and getting 4 new points. That part is very time consuming. All right, so here's the example I'm just going to run through this real quick and then we're going to do the try it together. The trapezoid ABCD, notice, and I'll just do it line for line, A2, 3, changed to A prime is now 3, 2. Notice that what was the X is now in the Y spot, and what was a positive 3 turned to a negative 3, and it went from the Y spot to the X spot. So your position, or I'm sorry, your X and your Y flip-flop. And this creates a new point. And this new point, and I want to really point this out, because if you were to go to graph this new point is an XY. Don't think that this means that this is the Y. It's using a shortcut to make the numbers be right, but the new point that you create is still an XY coordinate that you would graph like an XY coordinate, okay? Notice with B, okay, B was 4, 3. Notice the 4 that was in the X spot is now in the Y spot. The positive 3 is in the X spot as a negative 3. Okay, and I'm not going to talk through the other ones. You guys kind of get the pattern. I would rather try one with you. So under this try it, we're going to use this rule. It says the coordinates of the vertices of quadrilateral HIJK are, and then they list them. Okay, that's the first thing we see. That's the first bit of information we need. Here's the original coordinates. Then it says, if the quadrilateral HIJK is rotated 270 degrees about the origin, vital information, right? It's going about the origin, which means we can use our shortcut box. What are the vertices? Underneath the word vertices, write this. Vertices means what's the point of the corner, right? The XY. That's what they want when they say vertices. They want the new H, the new I, the new J, and the new K, or the prime ones. So our answer, we want the resulting image for HIJK prime. So we're going to write H prime, I prime, J prime, K prime. And then we're going to write the new coordinates for each one of these. And you just have to go slow. Think through it in a very slow manner, and these are not difficult. It's just, you just got to slow down a little bit. So let's pull H out. Here's H right here. H is the point 1, 4, right? I just yanked that from right there. This is the X, and this is the Y. It's going, you got to know the degree, 270 degrees, which means we're going to come over here and we're going to use the 270 rule. Okay, that's the rule we have to use because it says right here, 270 degrees. So using that rule, okay, the rule is that the original X goes in the second spot and it becomes a negative. So the original X goes in the Y spot and becomes a negative. So +1 becomes -1. Got it, Corbin? You got that written down? Okay. The original Y goes in the X spot or gets written first, and the sign does not change. So there's the coordinate. And so if we were to graph this, we would graph this at X4, Y -1, because this creates a new XY coordinate using this little trick. All right, let's do the Y. I'm sorry, the I right here. Okay, the first number we're going to write, and it doesn't matter which way you do it. I don't care the order you do them. The first number that you're going to write in the ordered pair, is that our bell? Oh my gosh. Real quick, just write this down in your book. The number you're going to write here is Y is 2. The X is a +3, so we're going to make it -3. Just make sure you have those 2 points written down. Then you turn it positive. Because the negative. Please put my highlighters up. Please give me back my mechanical pencils and have a wonderful day. No homework. Yes.
Have a good day, Ms. Ford.
You too. Thank you guys so much. For those of you at home, no homework tonight. Go ahead and try to finish J and K. That's what we're gonna do in class tomorrow. And then we'll finish up this on Thursday with a Math Excel. And in meeting.
Can I